This video will introduce our work. Whole body admittance control of anti-saturation for quadruped manipulators with impact force observer. Admittance control enables compliant robot environment interaction but requires accurate external force information. Force sensors impose cost and integration challenges, while ground reaction forces during dynamic gaits degrade traditional estimators' accuracy. A dedicated observer must therefore estimate external forces while compensating for foot impact disturbances. Furthermore, traditional admittance control risks instability under large forces due to joint torque saturation or friction cone violations. This necessitates compliance strategies that inherently address actuation saturation. Our control framework is illustrated in the figure, where the STA observer with GRF compensation and the anti-saturation admittance controller are the two main modules. The former is employed to estimate the external forces exerted on the robot's end effector or the base during various gaits, and the latter utilizes the estimation result of the former for compliant control while avoiding unsafe behaviors caused by actuation saturation. For detailed information, please refer to our paper. We will present some experimental results in the following. We validate the proposed methods through simulation in Gazebo, and the quadruped manipulator consists of a torque-controllable quadruped robot, Aliengo, and a 6-DoF manipulator, Canova Gen 2. We designed two sets of comparison experiments to validate our approach. In the first set of experiments, we compare the performance of the proposed external force observer with the currently mainstream estimation methods, including momentum-based observer and its variants. Using the external forces estimated by the proposed observer, the second set of experiments compare the conventional admittance control with saturation limitation and the proposed anti-saturation admittance control. For the first scenario, we first compare the performance of various observers of the robot in stance gait in the presence of measurement noise and model uncertainty, where external forces are applied to the end effector or the robot's base. It can be seen that the proposed external force estimation scheme estimates the most accurately, suppressing both model uncertainty and measurement noise. We then compare the performance of these observers in trotting gait. The proposed estimation scheme can effectively suppress the fluctuation in the estimation results under trotting. For the second scenario, based on the estimated external force by the proposed estimation scheme, we compare the two previously mentioned admittance control schemes. We first examine the case where the second and the third joint of the arm is saturated due to end effector force. The output of ADMC remains saturated until the external force is removed, so that the actual position fails to track the proxy position and thus oscillation occurs. However, our method avoids significant separation between the actual position and the proxy position, thereby preventing the robot from oscillating. We then examine the case where the driving torque of the x direction of the base due to force applied to the base. The repeatedly saturation makes the robot controlled by ADMC oscillate violently. In contrast, the robot controlled by proposed controller can track the proxy well, resulting in no unsafe behavior.